Instead of asking a large language model what 1 plus 1 is and ranting about it all day when it doesn't get it right, today I'm going to show you how we can optimize our code review process and add a new set of eyes, which is an AI code reviewer. The tutorial covers key steps, including workflow trigger setup and permissions configuration, fetching code changes, leveraging GPT for code analysis, and finally, automatically generating insightful comments on pull requests based on the GPT analysis. Let's dive in. To register our workflow and make it visible on the GitHub platform, you need to make sure that it is in the workflows folder, which is a subdirectory of the GitHub folder in the root of your project. So if you don't have one, like in this case, make sure that you create this folder. Inside the workflows folder, we then create a YAML file with our workflow name. Like in this case, we are going to call it code review, since we are going to be using the workflow to review our code changes. The name parameter is what is displayed on the GitHub Actions tab on GitHub, and this is optional. In the event that it's missing, the workflow file will be used instead. So let's name it GPT code review. Our workflow is supposed to be triggered when a pull request is created or when there are edits on the same pull request. The other objective is automatically creating a comment based on the AI code review. So we need to give our workflow permissions, which are writing issues, writing pull requests, and also reading the contents. In GitHub Actions, a job is like a specific assignment or task that needs to be done. We define the jobs for our workflow file under the jobs section. Steps, on the other hand, are individual units of work within a job. To put it in other words, steps are a single task or action that contributes to the overall job. For reference, we want to create a code review job after a pull request. That's the overall job. What we're going to do to achieve that, i.e., check out the branch and send the Git diff to a GPT or AI for code review, are the steps. And kindly note that steps are executed sequentially in the order they are defined in the steps section. If any step fails, the job is considered failed. So in our case, our job is code review. The initial step involves checking out the repository utilizing version 4 of the Actions checkout action. This action is responsible for fetching your repository, enabling the execution of scripts or additional actions on your code. Following the repository checkout, we proceed to utilize the git diff action, a GitHub action developed by Grant Berkey. This action is designed to collect the git diff of a pull request in either JSON format or the standard git diff format. Our objective is to conduct an audit of the changes in a pull request using this specific action. We assign an ID to the git diff action. This enables us to later refer to the output of this step in subsequent steps. Using the with keyword, we can configure this action to serve what has changed in a text file. File output only, we will configure the action to output the diff files only, limiting other potential outputs. The value is enclosed in quotes to ensure it is interpreted as a string. Now, let's tackle a crucial phase in our application, code analysis using GPT. We are setting up a code review step with a powerful large language model. In this tutorial, we'll be using GPT-4 from OpenAI. However, GPT 3.5 works just as well, so feel free to choose a model that suits your needs without breaking the bank. To execute this step, we will use a curl command to send the git diff to the OpenAI API for GPT-4 analysis. Using the run keyword, we define the sequence of command for this step. The process involves extracting the git diff output from the previous git diff action, and then posting that git diff to OpenAI. To achieve this, we use the pipe character. We previously instructed the git diff action to save the output to a text file. So let's use the cat command to read the contents of that file and save that in the changed code variable. Next, we are using the echo command to show the git diff on the console. I just want to make sure I haven't been talking nonsense for the past few minutes. Let's commit our code changes and also correct the typo on the version of the checkout action step. There's a V missing. After pushing our changes, we then create a pull request to trigger our workflow to run. On our pull request, we can see that our workflow is actually running, and when we inspect the output of the workflow, it shows that the git diff is being shown on the console as expected. For our GPT integration, we need to create an API key on the OpenAI platform. For lack of a better name, I'm going to call it GPT workflow with the typo. In our integration, we are only concerned about the completions module, hence we grant the API key write permissions for that module. We then use GitHub secrets to securely store our API key. To create the secret, navigate to your repository settings, click on secrets and variables, and then add a new repository secret with a name, for example, API key, and the actual API key as the value. The secrets are encrypted and they provide a safe way to manage sensitive information for authentication or other purposes in the workflow. Repository variables are created the same way as we do secrets, but the only difference is that they are not encrypted. For our workflow, create a variable for the code review prompt of your choice. The prompt used for this tutorial is in the comment section below. After the setup is done, let us go to the OpenAI docs and copy the kill command used to make API requests to the OpenAI chat completions Gpt-4 module. And then we replace variables like the API key with our own. We reference the prompt, which is defined in the environment variables by using vars.variablename. For secrets, we use secrets.the secret name. We also supply the git diff, which are the code changes made as a parameter to our kill request. For further processing, we save the kill response in a variable called response. Let us test the code analysis step using echo like we did before. Commit the changes and push for the workflow to be triggered. We can observe that our workflow is running and a post request is being made to GPT-4 for processing. By default, kill will show the progress of the request. If you don't need this level of verbosity, just add the .s to the request, which is the silent mode. That way, only the final result is shown. We've successfully posted the Git changes to GPT-4 API and received some feedback. So the next step is using the GitHub API to automatically create a comment on our repository based on the GPT-4 code review. Let us save the code suggestions in a text file so that we can be able to use it in the final step. But before moving on to the final step, please subscribe and comment if this video was useful to you in any way. Now that the bagging is done, in our final step, we use the cat command to read the code suggestions text file created by the Gpt-4 code review step, and then we supply the suggestions in the body of our GitHub API post request for comment creation on the pull request. The moment of truth. Let us commit and push our code changes and observe if any comment is created by the GitHub Actions bot after our workflow runs. The code suggestions have been added automatically through a comment on the PR, which was the intended action. Thank you for watching. If you made it this far, please consider subscribing, as I will be publishing other cool workflows.